So just want to talk about NumPy, and please stop me at any point you feel lost or you feel that you're not following again. I'll explain further. So NumPy is a package. It's a Python library. So it's just like writing different Python codes and package it so that someone else could just reuse the code. That's just what this library is about. So NumPy is a Python library, and it's used in working with arrays. I want to work with matrices, vectors. NumPy is very good for that. And as the name implies, NumPy, the NUM stands for numerical, gotten from numerical and Python. First three characters of numerical and first two characters of Python, they were combined together to get the name NumPy. So the aim of NumPy is to provide an array object that is 50 times faster than the traditional Python list. So working with Python list is not efficient. I mean, it could be time consuming, but with NumPy, you can actually get a faster computation. So now, the first thing you will do is to install. If do you have a copy of this notebook already? If you have it, just say it, please.
Sorry, we can't see the screen.
You can't see the screen?
Yes.
Okay.
I can see the screen from my end.
Cool.
And also know that you are supposed to download this notebook. It's on EduFlow. I opened week 4, live section. You can download it from here. I already uploaded it some time ago, so you can go to EduFlow, download it so that you can follow. So now I just increase this. Okay. I hope I can be able to. Okay. Yeah. So the first thing is to install the package. Yeah, while installing, we use pip. Pip, that's the stockage, the package was packed or bundled together and it's on pip. Pip is you could check for pip here. Pip. Yeah. So this pip. Anything you want to, like if you want to use, if you don't know how to install NumPy, you can just come here and look for NumPy. You search for it. So it will tell you to show you this is NumPy and this is how to use it. Pip install NumPy. You copy it. You can install it from your notebook. You just type this percentage NumPy. You run it. That I just hit Shift Enter. So the requirements are already satisfied because I've already installed this NumPy before now. So, but for you to use it, you have to install it first. After installing it first, you don't need to install it again. Anytime you want to use the package, it's already installed. So that's it. Then to use, sorry, to use NumPy, you import it. After installing, then still is the import. You have to do this one anytime you want to use it. If you restart your kernel, you have to import it again. Import NumPy as NP. So is this like an alias? So you can just say import NumPy, but here I want to give it a name. The same thing you did in your SQL. You say maybe you want to name a column. When you say that select, maybe select table.d, this table.this, I mean, or whatever. So as, so the same thing here, import NumPy as NP. So anytime I want to use NumPy, we'll use NP instead.
Excuse me, sir.
Yeah.
Please, I didn't get what you said about installation because I went out of network.
Yeah, I say to install, you just use pip. Pip install NumPy, this line. So if you are installing from here, from your notebook, you have to use this percentage. You can either use percentage or you use this sign. You see this, I think it's exclamation sign, yeah, one, or you use percentage, any of them, use it to install from your notebook. Okay. When you run this, it will install. Then the next thing is to import the package. So we're importing this numpy, we're importing it as np. So the next thing here is, okay, after importing, we want to create a list. We want to create a numpy array, an array. So this numpy np that we've installed, but we've imported it here, numpy as np. So there's a method array, is to create an array. Two ways you could create an array. You can create an array using a list. This is a list. We want to convert this list to array. So I say np.array, then inside the bracket, we put the list we want to create the array. Okay, I didn't run this. All right, then. So this is the array. Of course, looking like list, but it's not a list. It's actually an array. You can check when you need to reduce this a bit. Sorry. Okay, to check from here, let me just create another cell. Let's check scores. Type. So you see, it's numpy what? ND array. This ND means n dimensional array. Okay. So that's the type of this. It's not a list, it's an array. Now you can also create an array from a tuple. This is a tuple. This tuple, just wrap it around this array. Use this array to wrap around it. You can also create an array from there. So this is also an array. All right, so the next thing here is, now let's check the dimension of this array. First, let's create 0 dimension. 0 dimension is just one element inside it. So this score, I call the score np array 89, just one singular element. If we run this, you discover that this is the score. I'm printing the score here, 89. So I'm printing the dimension of this score. Score.end dimension is 0. 0 dimension means only 1. Remember, in programming language, most programming languages, the first always use 0 to represent the first item. So this means that this is a one-dimensional array. So the shape also, since it's just one, it doesn't give anything as the shape. You see the essence of the shape when we get multi-dimensions. So the next thing here is this for 0 dimension. Then for 1 dimension array of vectors. Vectors is not 1 dimension because it is 1 row, okay? 1 row. Just once it could be 1 row, many columns. That's a horizontal vector. A vertical vector could be many rows, but 1 column. So it's known as 1 dimension. So 1 dimension here, creating student score. This is a 1-dimensional array because it's in a list. Just a list, maybe having a list that has 1 row and many elements in that row. So this is the list printed here from here. So this one will print the dimension of the list, which is 1. This is the shape of the list. There are 4 items in the list. Then let's look at 2-dimensional arrays. That's matrices.
Sorry, excuse me. So
Okay.
So this one you just said now, this student scores.
Yeah.
Yeah. The third line, print student scores dot NDI, n dimensional.
And yeah, is to get the dimension.
No, yes, and guys, you said it's an n dimension, like the meaning of that NT.
Yes, n dimension. Yes, the number of dimension. How
And
many
it's one,
dimensions? Yes, it's one. That's
okay, like one row, right?
yes, like one row. Yes.
Okay, sir. Okay, sir.
But not just because, okay, yeah, because it's one row. Yes. If you see now, this one will give you how many dimension? How many dimension is this? Before I run it.
This is 3 dimension. That is 3 rows.
That is not it. That's where okay, that's where the confusion is coming from. Now see, we know that we have scalars, okay? In normal mathematics, we have scalars, we have vectors. And scalars, vectors, what is the multi-dimension, this thing? We call it tensors. Tensors, when the tensor has one element, if a tensor has one dimension, it is known as scalar. A tensor of 2 dimensions is known as vectors. A tensor of 3 dimensions, I mean, from 3 dimensions, there is no really a mathematical term for it. So, okay, tensor of 0 dimension is scalar, 1 dimension is vector, 2 dimensions are matrices. Okay, when you have x and y, when you can represent something as x and y, that means it's 2 dimension. X, y, 2 dimension. If it's only x, no y there, so it's just 1 dimension. But if it's just one item only, so look at this. Maybe let me just create another cell here. Let me create this cell. Insert cell, sorry. This is 1 dimension. This is just 1 dimension. If I put this is 2 dimensions because inside this cell, there is another cell inside it. Now, if I come here now and I put another cell, this is 3 dimension. See, 1 dimension. Okay. I put another cell, 2 dimension. I put another one, 3 dimension. This is not, it's not the same thing, it's not the same thing with this. They are not the same thing. If you check, this one is 2 dimension because inside this cell, there are cells inside it. But inside these cells now, there is no other cell inside any of them. Get that right now. This one, there is a cell here. Inside it, there is another cell. And inside that other cell, there is another cell inside it. Take, for instance, let's do this. If we say this, 2, 3, in normal list, okay? Let's say that R is equal to this. I can access the first item, 2. I can access the second item, this. Now, if inside here now happens to put another list, let's say 4, 5. This is 0, this is 1, this is 2. So I can access 2, which is this. Okay. Then if I want to access another item inside this, if I want to access the first item inside that, I have to use what? I have to use 0 to access this first item. That's after accessing this one, then I have to access another one inside it. What if inside this other list, I have another list inside it, maybe 6, 7. Now, if I want to access, if I just access this, let's say this is 0, 1, 2. If I go by 2 of it, I will get this. Then if I want to access an item inside this, maybe the first one, So I've gone 3 levels. I don't know if you understand, Uchenna.
Yes, I'm following, sir.
Yeah, so you see that when there is a list, just one list is how many dimension? 1 dimension. If there is a second list inside it, that list is 2 dimension. That list that is inside it, if that list contains another list, that is the 3rd dimension. So you see here now, since there is a list here and there is another list inside this list, and this other list that is contained inside the list, inside this list, that's why to access it, I have to go 1st dimension, 2nd dimension, the 3rd dimension. So if maybe this one contains another item, another list, maybe 8, 9 or whatever, even if it's just one item, to access that one, okay, this is 1, let's say we use 2. We are getting the 8. Then to access the item inside that one, we are moving to the 4th dimension. So that's the stuff there. So now going back to this, but just focus on 1 dimension and 2 dimensions here, because most times you will be working with vectors and matrices. You may not necessarily go beyond that in most works you will do. So this is students' scores. You see how many dimensions here? This has 2 dimensions as been suggested here. Now, let me ask this question. If I have this list, someone should tell me how many dimensions this list has. Us, S.
2 dimensions.
It's 2 dimensions.
Okay, that's good. Okay, what if I have this? How many dimensions?
That is not 3.
Okay,
That's still 2 dimensions.
sorry?
3
It's still
dimensions.
2 dimensions.
I heard 2 voices. Can you say it?
Two.
Okay,
2
Paul, you said 2
dimensions.
dimension. Okay, who else is talking?
2 dimensions.
2 dimensions. Okay, yes, it's 2 dimensions because we have 1, we have 2. Okay, what if we, maybe I come to this one now and I say this. How many dimensions?
2 dimensions.
Say 2
3
dimensions.
3 dimensions.
Okay, if you say 3 dimensions, why?
I say 3 dimensions because this 5 I've made it the 5 in the bracket I've made it 3 dimension. So for you to access this 5, it has to be s into s
I think
into
it's still 2
2.
dimensions for me.
Okay.
To me,
Okay, now hold on.
to me it's 3.
Now,
It's 3
okay,
dimension.
now let's relax a bit. The person that said 2 dimensions, now I want you to do something. I want to access this 5. I want to bring out this 5. How do I access it? Just
So
tell me
it
what
will
to
be-
type.
So it will be
S, right?
S equal to
No, just
0, 1. So that would be 1, 0, comma,
comma,
then 1,
mm-hmm.
then create a new distinct bracket.
Okay.
Then 0,
0, okay.
0, 1.
Is that all?
Yeah.
So let's run it. It's giving us error. These indices must be integers or slices, not tuple. So
Yeah,
in a
it's
list, you
wrong.
can't access a list like this. Okay.
Yes, 0.
Someone else tell me how to access this 5.
No, this one has to be in outside of the bracket.
Outside, okay. This, right?
Just a moment, please. Let me read what you just typed.
All right.
0.
Integer is not subscriptable.
0.
Okay. Let's do it one after the other. Let's start with the 0. This
0
is
is
0. Is that what's supposed to be? 0 is 7, right?
Yes.
So what should it be if we want to get the first level?
So after 0, could you try 1 now? Let's see if we can get the first.
I
We
think we'll
can't.
do 0, then we'll do 0 again, and then we'll do 0 again. That's we'll have
Now-
three zeros, each of them inside a square bracket.
Now, see, first of all, you do it one by one. If you do this, we've done this one, it's giving us 7. So can we access any item in 7? There's no, this is just 7 now, not an item in 7. I don't know if you understand. So we've done this one. This is how this is the highest we can go with S0. Because it's giving us a number, not a list. So we can't move further. We've gotten to the root. Okay. Now, see, let's do 1. If we do 1 here, 1 is giving us a list. So once we have a list, that means we can go further. I don't know if you understand.
Yeah.
Do you understand?
Yes.
Now, if we do 2, 2 is giving us 8, 9. So there is a list. We can go further with 2. So we can now check, okay, this is a list on its own now. So if we want the first item in this list, we'll use 0. Okay, that's from this 2. If we want the second item, we use 1 to give us the 9. But now, what we are looking for 5 is contained in which of the level?
That
After
is 1.
7, at 1. Okay. So that is where this 5 is contained. Now, then since this thing is a list, we can still go further. So in this list, is this 5 in the 0 or 1?
Is in 1.
1. So move further again. Now, this is a list now containing 1 item. If we want to get the item in this list, what do we use?
0.
0 or what? 0 works, yes. But
I
how
think
else can
we'll
we
use 0.
use instead of 0? If we don't want to use 0, what else can we use?
-1.
-1.
-1, yeah. So -1 will go because we can either go from the left or from the right. All right. So we use 0. So you see how to access this level. So this is how many dimension now? This is 3 dimensions because I'm in 2 dimensions actually since sorry, let's just say 2 dimensions, 3 dimensions. This is the first dimension, the second one, and the third dimension. So do we understand now? If you are still confused, speak up.
So for
Okay.
me, I try to look at the number of brackets required to close either the open bracket or the close. If I'm starting from the left, you have 1 bracket to the left. Then moving from left to right, we have another 1 by 6. Then we have another 1 by 5. That's making 3. So to me, that's my own simple way of recognizing whether it is 3 dimension or 2 dimension or 1 dimension.
Oh, okay. Okay. That's okay. Then another way is that you just try to extract them one after the other. You can just say remove this one, call it V, and say V is equals to this. If you remove this one, call it W. This is W. W is equal to this. So you see that you have 1, 2, 3 items. So you can still take them back. In fact, you don't even need to like try to cram it or whatever. When we get to this arrays again, you can actually get the dimension directly from here. So just note that as we enter. So now this now gives us 2 dimensions. So do we understand why this thing is 2 dimension now? This student's course. Uchenna, do you understand this? Why this is 2 dimension?
I don't know why it is 2-dimensional because it's clearly showing me 3 here. And I even want to say 4 because of the outer bracket.
Okay. Now look at this. Let me just remove this. If I have 2, comma, this, how many dimension is this?
This is 1 dimension.
1 dimension, right?
Yes.
Okay. If I add this, how many dimension?
This is 2. No.
2, right?
Yes, this is 2 dimension.
If I add this, how many dimension?
This is still 2 dimension.
Still 2 dimension. Okay.
Yeah.
If I add this, how many dimension?
That's 3 now.
Why is this one? I mean, sorry. You said that this is 1 dimension or
No,
2
this
dimension?
is 2 dimension, I said.
2 dimension.
Yeah.
So if this is 2 dimension, why then is this one also 2 dimension?
I mean, you can't access them using one because they are not, it's not 1 dimension. I mean, if we want to get any of the item in the second list, we cannot get it using the first list because they are not in the same dimension. They are 2 different dimensions. Just like this 6.
Yeah, hold on. Let's uncouple this list again. Let's bring it here. Let's call it S. S is this list. Okay. So let's get the first item, this one. Okay.
Yes.
This is the first one.
Yes.
Is there any list inside it?
No. It's a list on its
Okay.
own.
Yeah. The same thing with this one. The same thing with the second item. Now, since we did this here, and we just got this one, that's the first dimension. If we enter into it again, maybe we want the first item inside it again. That's the second dimension. And inside here, we can't get anything inside 90. 90 is just a number, it's not a list. Okay? Do you understand?
Yes, I'm following it.
This is 2 levels. So we do the same thing. If you do the same thing for 1, you discover that 1 also will give you 2 levels. The same thing with this one also, 2 levels. You can't go the 3rd dimension inside any of them. So it's just 2 dimension. Okay, so the student's course. Now this is the student's course, it's printing it for us. This is like a matrix now. Looking at it, it looks like matrix. The first row, the second row, and the 3rd row. So this one will get us the dimension of this. So this is dimension 2. This will give us the shape. This is 1, 2, 3 rows, 4 columns. So a 3x4 matrix. All right, so proceed. Now I want to index. We've already done it now, so but let's still talk about it. So no. Okay. Yeah. So this, pay attention. The student scores. If you get the first item, sorry, not this one. I mean, let me print the student scores first. There are 2 things here: students scores and student scores. They are two different things. So this is the student score. So the first item, normally the normal stuff we know from list. The first item is 90. The second item is 45. While the last item is 100. Do you have any question on this? All right, no question. So the next thing here is, let's now go for student scores. So let me print this somewhere here. What's the shortcut of getting this? This, okay. Now, guys, I'll ask a question now. Given these student scores, what will be the answer for this first line if we print this first line?
That will
We
be the
print
first row.
the first row. Any other alternative answer? Okay, so that means we're in agreement. Okay, what of this one? The first, the students scores 1.
Next one.
Dancing Fayode.
Okay.
Yes.
So the student scores 1. What would be the answer?
The second row.
The second row. Okay. Yes. So Tower Cat, student scores -1.
The last row.
The last row. Okay. All right. Now Dom, student scores 0,2. Let me see. Sorry. So Dawakat, are you helping? I'm sorry, Dom, are you helping us out? Is Dom there? Someone should help him out.
Sorry, when you said 0,2, the last time we tried doing something like that, it was giving us an error that made it necessitate us using just one value inside the square bracket, but we can have 2 square brackets with 1 value each.
Yes, we did it in a list, but this is an array.
So instead of having 0,2, we can have 0, close the bracket, then have another bracket, then 2 inside.
Then open another bracket and put 2 inside. Yes.
That was when we were working with what? A list. This is list. But in array is different. Okay. In array, if you want to do this, look at this. This gives us 44. Now let's put this thing inside an array. np.array. So now our S is array. Okay, it also works with array, but alternatively, you can also do it this way. It will still work. Did you see it? For array, you can use this, or you can use this other one for array. For array, right? Sorry. Invalid thing, syntax, okay. Yeah. So this parenthesis was open. Okay. So in array, you can either index it this way or this way. So that's for array. But for list, you can only use this way. For array, you can use the 2 of them. Okay, with that knowledge now, we go back to this. So who can tell me what will be the solution for 0, 2? Festus. Festus, are you there?
That should be 78.
Okay. Let's try it. Let's put it here and run it. 78, correct. Rack. Rack, are you there? RACH. Hello, Rack. Okay. Please, do we have people that will just come, turn on their this thing to answer present and then leave? Okay, so Rack is not present in today's class. Dom, are you back?
Hi, I'm here.
You are there.
Yes.
So help us with this one, this line. Student scores 1,0.
I just joined the class. I don't understand this one.
Okay. Someone should help her out. Dom, are you back?
I think it's 44.
Who answered?
Sam.
Sam, okay. 44. So let's check. The second item, right? Which is this. Then the first one, 44. All right. So who will help us with the last one?
Yeah, I get it now.
Okay, Rack, you can answer now.
100.
100.
No, that should be 97.
Rack, why did you say it's 100?
It's, oh, sorry, the third row, sorry. No, 0, 1, 2.
Rack, remember that the first one we talk about the row. The other one is the column. So using this matrix, and we say that -1 is to get the last item. So this -1 is getting the last row. This is row 1, row 2, and this is the last row. Okay. So the last row in this, sorry, using this matrix, sorry, this one. Yeah. Row 1, row 2, row 3. So this last row, we use -1 to get it. That's what this -1 will get. Then inside this last row, we'll get the last column. Last column should be the last item in this last row, which is 97. Yeah.
Okay. I get it now.
You get it now? Okay.
Yeah, I get it now.
Cool. Okay, since you've gotten it now. Now, Rack, tell me, I want to get 99. I want to extract 99. Tell me what I'll write to extract 99.
Yeah, God. That would be 2, 2, comma.
Is it these two, right? Like this? Am I right? Comma what?
2.
2,2. Let's try. It's giving us 100.
Sorry. Okay. Sorry. 1, 1,2.
Why did you say 1,2?
The first row, like the first row and the third column. The second row and the third column, rather.
All right.
Yeah.
Okay. That's correct. Thank you.
you.
Yeah. All right. So now we'll go to sorting. We've already learned how to do sorting in lists, right? Abimbola, could you tell me how we can sort a list? Let's say we have this list. Yeah, let's go back to this our list. Let's remove this. We want it to be a list. Or maybe let's just use a simpler list here. How do I sort this list? Abimbola, can you remember?
Sorry, I can't remember.
Okay. Who remembers how to sort a list?
Yeah, sorry, sir. What did you say?
We want to sort a list.
Which list?
Any list. How do we sort a list?
In descending or ascending order, sir?
Okay, ascending order. David. David Madukwe. Are you there?
Yeah, I am here.
So how do we sort a list?
We use the sort
I
method.
think
sir.
it uses sort keywords.
How do I put it?
So that would be s dot sort in bracket.
Okay. So now let me ask you a question still. If I do this, will it return something? I mean, what does this thing do? You know, there are two ways you can. There's a method you will call. It will sort the list in place. That's it will change the original list. There's another one you will do. It will not change the original list. It will return the sorted list. What does this one do?
This one will sort the list in descending order and then return the sorted list.
Return the sorted list. Okay.
Yes.
Let's check. Let's call it T is equal to this. Then we'll do two things. We'll print the previous S, then we'll print this T. The T is supposed to, based on what you explained, the T is supposed to return the sorted list, right? Am I right?
Yes, sir.
Why this S? Why this print S should give us the original S, right?
I didn't mention about the S. I was only talking about the sorted list. Like
Of course. I said one returns, while the other one will just effect the change in the original list.
I think it
should be in ascending order.
Now look at this. The original list has been changed. Why the T is returning none? Because this one will sort the original list and it will not return anything. But if we say this, if we say something like sorted S, the original list remains the same, but it returns the sorted list. Take note of that, very important. Do you understand what just happened?
Please, sir, can you go over it again?
Yes, very clear.
Paul, you said what?
Please, sir, can you go over it again?
Okay. These are two methods. Sort S and this. Oh, sorry. S dot sort. Now see, two ways of sorting, sorted S or S dot sort. That's the list you want to sort. Here you put it in a bracket, put it inside this bracket of the sorted. For this one, it will take that list, sort it, and return the sorted list. And we try to confirm it here that after running this, when we call the S still remains the same. It was not changed. YT returned the sorted S. That's for this. While using this S dot sort, we change the original list and it will not return anything. So that's it. When we call the print S, the original list has been changed, has been sorted. YT does not have anything inside it. All right. So
Okay.
now, okay. You want to say something?
I think I understand it now.
All right. Thank you. So now when we go to sorting an array, this is array, the Numpy array. I just still created that student's scores. This is to print the student's scores. This one is just to print a new line. Then I want to sort this student's scores. Remember in that list, we did S dot sorted. So that means I have to sort the original list. So that's what will happen here. Now, we have, this is an array. For us here, it's a matrix. There are two ways of sorting. You can sort by rows. Like this one, once you say the axis equals to 1, it will sort these things, each row, it will sort each row. This is the original array. This is a sorted array. You discover that each rows were sorted in ascending order. In ascending order. Now, if I want to sort it column-wise, to sort by columns, this one does it. The only thing that changes here is axis equals to 0. I change it to axis equal to 1. That just this line does the work. This line here.
Sorry, sir. Does
Okay.
it mean that when you are sorting an array, it will automatically retain the original, unlike the other one that we did?
This
Because
one
we
did not. Sorry?
We use dot sort here, and I'm seeing two different results. One the original, and the other one the sorted one. So that's what I'm trying to ask.
I'm printing two things here. I'm printing the original here. And I'm printing the original again. After, this is the original before running this line. This is the original after running this line. So I'm just telling you that before we did this line, this was the original. But after doing this line, it changed the original.
Okay, okay.
Yeah.
Sorry, sir. Can you explain this as is equals to 0? I don't understand. Inside the
Yes, as is equals to 0 is I want to sort by columns. This thing was 90, 44, 98, but now it is 44, 90, 98. So this one was the same thing, 45, 77, 94. So as is equals to 0, we'll sort it column wise. While as is equals to 1, we'll sort it row wise.
so that can we imagine not passing any argument inside the sort method?
It will use the default. It will
And
use
what
the
is
default.
the default, sir?
0.
What do you mean 0? Like as is equals to 0 or generally?
Sorry, the default is to sort row wise. Row wise, which is this as is equals to 1.
That's the default. If we don't pass any argument.
Yeah, it's the default. Can't you see? We just remove the default and it's giving us sentiment as is equals to 1. So that's the default. Sort it row wise. You get it now? Do you understand?
Yes.
Good.
Yes.
Sorry, so I think I have a question.
All right, you may.
Yeah. So the sorting, must it be in ascending order?
This is ascending order.
Yeah, that's what I'm asking. Must it be in ascending order? Can't it be done in descending order?
That is the next line here.
Okay.
Yeah. In fact, there's something else I didn't, I think, did I mention that? Okay. You can invert a list. See this. This will help you with the next step I want to talk about now. To invert a list, let's say we have this list. Yes. So I can invert this list with this -1. It inverts this list. Okay. You see, this 2, 7 becomes first, followed by -2, 5, and 2. So that means that if I actually do this, if I want to sort this, another way of sorting this list in descending order is I can do this, then run this one on it. This one will sort it in ascending order. Then this one will make it descend. This one will invert it. But normally, this sort has another argument. I think reverse. Is it reverse equal to true? Okay. Maybe it's ascending.
You put D at the end of the reverse. I think that was why. There should be no D.
Okay.
Yes.
Okay, yeah. So reverse is equal to true. When you put reverse equals to true, that means you are sorting it in descending order. I know we've done this before now. So now coming to this place, I've checked Numpy documentation, I've checked resources online, and I didn't see any reverse method for Numpy, but this is a workaway to reverse Numpy array. I mean, after sorting, to sort in a descending order. So here I just did sort. You first of all do the sorting in ascending order. Then anything you get, you use this line. Now I'm using this to reverse it. That's to revert that ascending order. If you check this original list, after doing this sort, it prints this one, which is the ascending order. Then after that, I use this on it. It will reverse it. That's giving us in descending order. That's for Numpy array.
Excuse me, sir.
Yes.
This student scores equals to student scores, like the reverse order.
Yeah.
The one you used 2 columns and then -1. No, don't go. We are still on
Okay, this one. Yes.
You use 2 column, 2 semicolon or colon, then -1.
Column. Yes, -1. Yeah.
I used to think that in Python, this 2 semicolon is used to print in a list, to print out every second or third of an item in an array. For example, sorry, in a list. For example, if we have a list of, can we?
Let's just.
Yes. So just like create a list.
I just created one. This.
Okay. Now we have 4 items in this list. Now, if we want to get the second item.
Sorry. Okay. Okay. If we want to get the second item.
If we want to get every second item in this list. So we can do, because I used to think that we can now use this semicolon, then we call it normally step. Step, yes. So if you put another semicolon, then put 2, it's going to print out, it's going to jump, like it's going to print out 45, then yes,
it's
exactly.
printing out the first ones.
Yes.
Okay.
So if you put 3, it will jump to the other one. Put 3 and see.
This,
Yes, exactly.
Then now put -1. Put -1.
then it should start from behind, I guess.
It's when you
Start
put
from behind.
-1, when you put -1, it reverts the list.
Yes, that's true. That's true. And if you put -2, then it will step the list. It will do like that is a step. It will jump the list like
That
yes,
is
100,
145.
yes, and so on till the list
Yeah.
finishes.
Yeah. So to revert, this is enough to revert the list. So you see now after, okay.
No, I just wanted to get this clear because now I'm seeing it as it is used to reverse the list, and I know there is another
Use case. Okay.
Boolean value used for reversing list.
Okay.
Sorry, can you use single column instead of double column?
Single column means you're telling it to print everything till before the last item.
Yes. Yeah, you taught us this before.
Yeah, till before the last item, -1. But if you use double column, you are reversing the list. So this is another way of reverse. That's a way to reverse the list. All right. So now let's go over to the next thing. We want to generate random numbers. I mean, you will deal with random numbers a lot. You need it a lot. If you're a machine learning scientist or data scientist, there will be need for you to generate random numbers because you use it a lot in your career. So first, we want to generate random numbers, but integers from 0 to 50. That's what I mean is the numbers that would be generated should not be less than 0. It should not be more than 50. So this is it. From, the default is 0. I can say from 45 to 50. So if I run it again, it can give me different numbers, but it won't be, well, it will be between 45 and what? 50. Any question on this? I just did numpy mp dot random. Then which type of random number? Random integer number I want to generate. So the first one is if the lower, that's the, what do you call it? Is it the lower level of what? The lower bound. The other one is upper bound. Okay, you understand this, right? If you don't understand, you can ask. Okay, so the next one is,
explain again, please.
we are using numpy to generate a random number. We are using numpy to generate a random number, and this random number, we want it to be random integer numbers. So I want it, the lower bound to be 45, the upper bound to be 50. So we'll run this in as number of, we could keep running this, but what we are certain is that to give us random numbers, and those random numbers will be integers, and it will be between 45 and 50. Of course, we don't really call this random number, we call it pseudo-random because random, this is a computer program, and the computer program works with an algorithm. Since there's an algorithm, that means the random numbers, they're actually pseudo-random numbers, not perfectly random numbers. There's a formula that generates it. So, but we just take it to be what? Random numbers. So it keeps generating different random numbers each time we run it. It could be different, it could be the same. Since it's random numbers, any number could appear. Okay. Now, if you want to generate random numbers, but not integers, from 0 to 1. So this is the code in want numpy to generate random numbers, but these random numbers we want it to be rand. I think rand should be we have normally generated random numbers, we have uniform generated random number. Let's check. Normally, Abi. Okay. Generated random number numpy. Okay, numpy. Okay. If you want to generate random normal in NumPy, you use this. Okay, you use this normal, and of course, when you want to talk about random numbers, that's normal random numbers. There is mu and there is sigma. Okay, then this is the mu, this is the sigma. Then hold on. This NumPy documentation. So let's check the last item here. Okay, this one is sorry. Parameters. Okay, the mean, that's the center. This square is the deviation. The standard deviation. Then this one is integer or tuple of integers. Output shape. Okay, that's the shape you want it to be. Okay. So, okay, for random numbers is this. I mean, for random mean, then they should also have random uniform numbers. This normal, out of uniform. If there's no uniform, let's check this. Random values in a given shape. This is convenient function for users plotting code from MATLAB that wraps random sample. Okay. Create an array given the shape and populate it random samples from a uniform distribution. So for uniform distribution, that's the one we are using. So yes, but there should also be this one, standard normal distribution. So you see this is the documentation. I mean, anytime you have a challenge, you want to find out something, the best place to go is to go to the documentation. So now we've been able to see that the one we just use is for uniform distribution. So if you go here and you check this, we've used this one for random integer. So why this one is for standard, this one is standard. That's the standard normal distribution. Why, if you want to specify the mean yourself and the standard deviation, you can use this. You can use the other one, the random normal. Random normal will allow you to specify the mean and the standard deviation. But if you just use the one we are using now, so that this one means the mean is 0 and the deviation is what? 1. I think that's a standard normal distribution, which is this. Okay. So you see, so it keeps giving you different random numbers. Yeah, then this one is if you want to generate a one-dimensional array, like you want to generate a vector of random numbers, this one wants it to contain. All right.
This float, I don't know, this thing is stopping me in my head. 0 to 1. I've been trying to wrap my head around it. I still don't understand. Random number or in float, that is float, right? 0 to 1.
Yes.
Can
Between
you give
0.
Can you give some elementary examples, please? Because my head is not getting it at all.
This is an example. Now, this is an example. Now, in this example, this answer here is bigger than 0 and it's less than 1. Do you understand? You just want to generate numbers that are between 0 and 1, but they should be greater than 0 and less than 1.
Okay.
Yes, but the distribution is picking it from random and from standard normal distribution.
Can we try 2, sir?
You mean what?
Can we try 0 to 2? Is it possible?
For this?
Yes.
For this one is just this. We'll get to that. For this one is just this. From 0 to 1. If you want it to be from 0 to 2, you have to do a wrap around. You have to wrap around it. Maybe you can say plus 2. Even if you say plus 2 here, I mean, essentially you can just say plus 1. So you see, whatever you run here will be what? It will be, although this one now will be between what? It will be between 1 and 2. But if you want it to be between 0 and 2, this is what we can do. We want the first one, we want it to be greater than this, less than this. Let's think about this now.
I think this random method we take in some argument.
This documentation. So rand. Okay, in a given shape. Can you see the argument it takes in?
This is for
This
matrix.
is the dimension. That's it. I mean, it does not take any other distance. The only thing it takes in is the dimension. This is the documentation. So if you want to generate random numbers, which I did here, for this place, we want to generate a 2 by 3 random numbers. These 2 rows, 3 columns. You use that. It does not take in any other argument. Remember, they already said that this random is standard normal distribution. We know a standard normal distribution mean is 0. Standard deviation is 1. So that's just it. Yes, so it is standard normal distribution is from between 0 and 1. You can't make it to be between 2 and 1 or between 3 and 1. You can't do that.
Okay.
Yeah.
So the argument that the method takes is just for the matrix output.
Yes, exactly.
Thank you, sir.
Yeah, like this one now, if you decide to add another thing here, maybe you add another, maybe 4 here. You see it generates a 4-dimensional, sorry. It takes the first one. This thing should be 2. If you check here, 1, 2.
It's
And
2
for
matrix.
Yeah, 2 rows. So for each of these 2 rows, you have 3 columns. And in each of those column elements, there are 4 items inside them. So you can actually start assessing this. You can assess the first one, this. You can assess the second one. Let's say the first item in the second one. You can assess the first item in the third one. So you see, this is 3 dimension because this is first dimension, second dimension, third dimension. The first dimension is 2 rows. Second dimension is 3 columns. Then in that 3 columns, each this thing in that column contains 4 distinct elements in them. So yeah, let's go back to this place. Just here to generate this. Then this one, standard normal distribution. So this one is, we want to generate here a 1D array containing 4 random integers. So, but these integers want it to be from 0 to 70. Since it's 4, the size is 4. I mean, once you just put 4, just put only one item in this size. That means we want 1 dimension, which is this. If you want 2 dimensions, you can put 2 items. Like if we put maybe here, we put something like 3. You see, it's a 2 dimension. What don't you understand?
From the heading, you say generate a 1D array.
Array.
1D, 1 dimension. Okay.
Yes. How many dimension is this?
This is 1 dimension. Yes, because
Good.
it's just 1.
Exactly. So because inside this size, we added only one thing. Okay. Do you get me?
Yeah. Can you please explain the argument there?
The first argument is that we want this thing to be between 0 and 70. As we want it to be maybe between 50 and 70. We can just say here 50, comma 70. That's the numbers it will generate will not be less than 50 and it will not be more than 70. Okay. Then this size here is, what is the size? We just want it, we want each and every one of these. Like this one now, just give us, okay, numbers between 50 and 70. Okay, that's the numbers we want to be. then want it to just have only one matrix. I mean, one vector. That's a row, one row only. And that row should contain 4 items. What's this? Let's check. Okay. Shape mismatch. Objects cannot be broadcast to a single shape. Okay, hold on. Let's check. Let's go back to this documentation. I want to check something. Random integer, okay. Low, high, okay. Size, all right. So if we want to achieve this, what we wanted to do before, it would be 50, comma, this, yeah. So instead of,
I
yeah,
think
that's the
there is no bracket inside.
yeah, no bracket. So the first one, that's if you didn't put the 2, by default, it will take the first one to be 0. You understand?
Okay.
Yeah, so I think it's also stated here, I think so. So this one is see low, high.
So
So
if you
high,
omit that low, it will automatically default it to 0.
yes. But even upon that, with random integers from low to high, exclusive. Low is inclusive, high is excluded. But if that's the case, and they say that by default, high is equals to none, that means that someone must provide low. In that case, if we have just one, it should be, I don't know if you understand what I understood
I'm
from this
following you,
expression.
but I'm trying to understand it. I'm following you, sir.
Okay,
Because
so
I'm confused if they say that the low is exclusive and high
no,
is inclusive.
no, look at
High
this
is
here.
exclusive.
If by default high is none, okay, if high is none, that means that the user has to provide low. Okay, there is something else they state here. They say that if high is none, the default, then results are from 0 to low. Okay.
So that is in descending order.
No, not necessarily descending order. We mean, what it means is that if someone did not provide this high here, if someone just provide only one, so it will now account from 0 to 70. We provide only 70 here, so the default will be from 0 to 70. Of course, it won't show 70. 70 is excluded, but numbers from 0 to 70. But then if you provide the first item, it will count from that first item to this one. Okay.
Okay, sir.
Yeah, so this one size, once we put one item here, just that one item. But for 2 dimension now is that instead of one item in the size, we're putting 2 items. That means we are telling it we need 2 rows and 3 columns.
Sorry, can you run line 104 again?
Again? Yeah. Again.
Okay.
Again. Again. All right. Okay. So the next thing we have is generate 2. Okay, we've done this. So the next thing is iterations. We want to iterate through this. So this student's course. Okay, we created it again in case we change something. Now, we want to iterate it just the same way we were doing in list. So we can actually iterate this the same way in list. For student in this student score, we want to print student. So it will print the first one. Okay, it prints the first one, the second item, the third item. The same way we were iterating in list, the same thing here. Then this is row wise. What if you want to iterate column wise? Let's say we have this list. We have student score. We have, okay, sorry. And put it here. Okay, here. Let's just do it here. Okay, this is student scores. This. What if instead of iterating this way and this way, maybe we want to just get this first, then get this next. I mean this, and this. We want to move column wise. Column wise.
You mean getting the individual items?
No, what I mean is, remember from when we did this, we are moving row wise. We are picking each row first. We pick the first row, pick the second row, pick the third row. What if instead we want to pick the first column first? That's 90, 44, 98 first. Then we now pick the second column, 45, 77, 94. Next, we want to move column wise instead of row wise. To do that, the best thing to do is, one of the things we could do is to invert, to transpose the matrix. Am I right? I have a matrix. If I can access the rows, if I transpose that matrix and try accessing the rows again, what I'll be accessing actually is the columns. Mathematics students, those that did mathematics in JSS3, JSS2, you know Junior WAEC.
Thank God we did not do mathematics.
In JSS3.
From JS1 to university. Thank God.
Okay. So guys, we just transpose means you are reshaping the matrix. Now let's transpose this matrix, this student score. Let me just show us the transpose here. Oh. Okay, we'll print this one first. Now I want to print the transpose. To transpose is just put dot T. We'll transpose it. This thing only works in array, does not work in list. So let me print this. Let me leave a space in between them for visibility. I'm leaving 2 spaces. So this is the original matrix. Array or matrix. After transposing it, we get this. You discover that the first row is now the first column. The second row is now the second column. The third row is now the third column. The same thing happens that the first column is now the first row. The second column is now the second row. The third column is now the third row, while the fourth column is now the fourth row. With this now, we can then use our normal iteration. So I think I explained that here. So this thing, I just transpose the matrix and assign it to this. Then I'm not printing. This is a transpose matrix. Then I'm not looping through it for C in this transpose matrix. I want to print C. You discover that I now ended up printing the words, each of the columns. You can ask questions based on this.
So is it possible that we can iterate over this array and then get the individual items? Because I am just thinking of the possible way, and the only thing that is coming into my head is what do they call it? What they call this type of looking again.
But wait, first, what the aim of this particular stuff I introduced now is to tell you, teach you how to transpose a matrix. Did you learn how to transpose a matrix now in Numpy array? Do you understand how to transpose a matrix now? Do you understand how to transpose a matrix in Numpy
Yes,
array now?
yes. As you have explained it now, I understand it
Good.
now.
Okay, good. Fire, do you understand how to transpose a matrix in Numpy?
Yes, a bit.
The only way of how to transpose a matrix is just do dot T. The matrix will be transposed. Do you understand it now?
Yes, yes, yes.
Good. That's just what happened. This is the original matrix. I just added dot T to it. It will transpose it. I also showed it here for simplicity. Here, this is original matrix. Then when I added dot T, it transposed the matrix. Okay?
Okay.
Okay. So now, then what I now did is that I now entered into this transpose matrix and I'm printing the rows of this transpose matrix. This is the original matrix. This is the transpose matrix. I'm now printing each of the rows of this transpose matrix, which is this, this, this.
Sorry, sir. When you say transpose, what do you mean by that?
Transpose is that you take all the columns, you make it the rows. Like here, this is the original matrix here. This is the transpose matrix. If you check here, in the original matrix, all the columns, which is 90, 44, 98, was the first column. First column. It now becomes the first row. You understand?
Yes.
Opemi, do you understand?
Yes, I understand. Thank you.
Yeah. Okay. So, okay, yes, I wanted to talk about something else. Now, it's possible that if I go to this student's course, the student's course. Now, let me comment this out. This is the student's course. I enter the student's course and I'm printing each row, and each row. It's possible that when I print one of the rows, I can also print the items in each of these rows one by one. I can print the items of each of these rows. So how I can achieve that is?
That was the question I was asking you, sir.
Okay. So this thing now is that, and I'm not saying for student in this student's course, instead of printing it, then also in these students now, I want to enter each item since this students now contains a list. That means that at each stage, I can actually print each item in it. So first is that this student in this student's course, the first student will be this one. So I now entered into this first one from here. I create another loop inside it. So I'm saying now for score in each of these students, I want to print the score. So that's it here. So this one will print, that's this one. It gets to this one first. The first student is this. So in this first student, now I want to enter this first student from this loop. Now I'm entering this first student that is printed here. I'll enter it with score and print each item in it. So this is the first student. Then this second loop will now print these items in this first student. So the same thing will happen here. The second student, the second thing is there. So if I cover this print here, you'll discover that to just print all of them. This is the first student. I think the second one, yeah, I mean, sorry, I think first, second, and third, something of that nature. So if you have a question here, you can ask.
So this is a nested loop, right? In Python.
Yeah, nested loop.
Yeah. Now, can we use while loop to achieve this same thing we just did with nested loop?
You can.
Because the while loop will be going for the index numbers of each item.
You can also, first of all, before we even talk about the while loop, maybe let's try to recreate it with for loop again, but the for loop that uses another method. That uses this. I think I even made mention of that here, but that was in another operation. But now let's recreate this. We can actually get the dimension of this. Okay. Let's say for I in the range of the dimension, that's the length of this student. For I in this, okay. Then we can also then say for J in the range of, hope this will not get complicated to you. All right. In fact, even this, what I'm doing now, if you don't really understand it, later on you go back and watch it, you can just cool down and look at it very well. You will grab it, but I'll try as much as possible to explain it. So this one will get the range. I is moving from 0 to the number of items in this.
So can you get that student score and paste it again so we can be looking at it as well? Typing this.
Okay.
Yeah, I think it will be better.
Okay, so now this is the student score.
Yeah.
So now moving, we are getting the range of the whole of this. That's the length. Wait, this is array. Since this is array, sorry, then what we actually need is this. This is an array. This array has a dimension. This is the dimension of this array. R, comma, column. Let me say the rows. How many number of rows? Columns is equals to the shape. So this student dot shape. I'll print this. Let me create another list for this. Let's print. Let's just return this row and column. So this gives us the shape. It's telling us that there are what? Three what? Three rows and what?
And 4 columns.
4 columns. Okay, yes. So now we can then say for I in the range of the row. Sorry, here. For J in the column, the range of the column, we want to print. See what we want to print. We want to print what? The student score, the row, which is I, and the column, which is J. So the row, for I in the range of the row count, number of rows, for J in the range of the column count, we want to go to the students column, we print the I, we print the J. If I see something else we could do here to make it visible more, we can just print here. Here we can print this. Let's print the I with all the columns. So just achieve this. See what this one is doing. Student scores. For I, when I is 0, it will print the 0 item, the 0 row with all the columns. This is 0 row, but all the columns. So when I is 1, to print the second row, that's the 1th row, second row with what? All the columns. This thing here means print all the what? All the column.
Yeah.
So the same thing here. So this one is equivalent to what we just did up here. Then using this method also, it's possible for us to even print the columns. To repeat this thing, we can repeat this.
Can you bring your screen down, sir?
Sorry?
Yeah, okay.
Yeah, this that here we wanted to print the from here, yes. We wanted to print the columns, to print those those things column by column. So this row in this, we can actually if we want to print the column, so actually we need the column. So want to print each of the columns, we can just call this for J in this. But now we'll print all the rows but the columns. So I mean, in case you run this in future.
So actually, we can use this method without transposing it even.
Exactly, yes, without transposing
so it's optional.
it. Of course, it's optional. There are many ways that leads to the market. Yeah. So I think it was here, yeah, from here. So here we see that this is the column, the number of columns. So you can just look through the number of columns. So we want to print student score, but we want to print each of the columns, all the rows in each column. That means you get to the column, you print, you pick one column, column 1. If you pick column 0, then all the rows inside it. You pick column 1, all the rows inside it. So that's just the stuff there. Yeah. So when you go through these things, they are very, very easy for you to understand. Then the next thing I want to talk about here is, I don't want to talk about this, but on your own, just try and look at it. Now, let's do some little calculation with NumPy array. This is the power of NumPy array. Now, I first created this thing. Let me drag this. Should be possible to drag this thing down, or I can move it down actually. Move it down, yes. Okay, so I created this random number. This NumPy, from NumPy, create a random number, and I want it to be random integers. I want it to be numbers between 0 and 10, and I want the size to be 7 rows and 5 columns. So that's it, 7 rows and 5 columns. All right, so now I want to multiply this with itself. NumPy, I want to, maybe someone asks you to multiply this or even to square it. This is the multiplication. I'm multiplying this with itself. So it will be what? 1 times 1 is 1, 7 times 7 is 49. You just, this number, multiplying it by itself. You can't do this thing with Python list. You can only do it in what? NumPy array. So you can also add a number. We're adding 3 to this number. You can add a scalar to the vector, to the matrix. So you see that this one now that is 3, 2, 3 here, we now have 5, 6. It automatically broadcasts this 3 to all the items in this matrix. So you can also add the matrix with itself to give us this.
Excuse me, sir,
So
where did you get the nums variable that you're using?
This is the nums variable here. I can explain it. I generated the random numbers.
Oh, okay. No.
Yeah.
Oh, okay, okay.
So you can also, okay, I've talked about adding it. Okay, the next thing is you can subtract none from none, which will give us 0. So you can find the logarithm of it. NumPy.log. This is the logarithm of this. Yeah, it's giving us warning because it was divide by 0 encountered in logarithm of this. Let's check. Do we have a 0 here? We have a 0 here. We have 0. So when you are doing logarithm of 0, normally should be infinity or minus infinity. Yeah. So that's it. Then you can also find the exponential of that. Yeah, that's all for that we have for NumPy array. I mean, if you have any question, ask. Can discuss now.
Please, sir, I will appreciate the practical application of this, please, sir. Just is
Practical application.
simple practical application.
I mean, we just did the application now. Logarithm of a matrix, exponential of the matrix. Maybe you want to do logistic regression, and you're writing the code for logistic regression. The code there's a logic there which is exponential. You have the data sample you have. The data you want to model is a matrix form. So you want to find the exponential of that number. You want to find the exponential of that matrix. This is how you find the exponential. NumPy.exponential this. I mean, this is just is a normal application of it. You can find the logarithm, you can multiply them, you can add them, you can even do cross product and dot product and all those things here. So I don't know if there's any particular application. I mean, these are things that you use in machine learning.
So we are going to be using this algorithm very well, or just a few times, because I hate this algorithm with passion.
Which algorithm? NumPy?
Anything algorithm.
You mean NumPy?
No. Algorithm, not the NumPy, just algorithm like this. Sorry, not algorithm, I mean logarithm.
Okay, logarithm. I mean, why would you hate it? You're not computing it yourself. You're just telling it compute logarithm. So,
Even the word log, I just.
oh, interesting. But do you like exponential?
Of course, it's not very well.
And
Logarithm in school, so that's why I hate it.
oh, okay. But you know that you can find exponential logarithm of exponential should be right. What's happened? Okay. NP dot exponential of this. And it gives you what? It gives you the original matrix. You know that? Huh?
So logarithm is even like a method also in this Python.
No, logarithm of exponential will give, if you say logarithm of exponential of x, to give you back x. So it's just like logarithm is the inverse of exponential.
It's just like inverse of absolute numbers.
Just like what?
Inverse of absolute numbers.
I don't
Like,
understand.
I think it's just like anti-log.
Okay, yeah, because absolute number does not have a unique inverse. I mean,
like what I meant actually in Python, when you absolute value of a particular number is just like the opposite of that number. So
no,
reversing.
it's not the opposite of that number. Absolute value of 4 is what?
4.
Absolute
4.
value.
Absolute value of 4 is 4, and 4 is not the opposite of 4. It's when it's absolute value of minus 4, it will give you 4. And now is that okay, if you say absolute value of minus 4 and it gives you 4, that 4 that is giving you now, if you ask you go back to what it was before, the absolute value, you can't go back.
So you mean absolute value of 4 will not give me -4?
No, it will give you 4. Absolute value means just remove the negative sign. If there is a negative sign, if there's no negative sign, let it remain the same.
It works only for negative signs.
Sorry?
It works only for negative signs, sir.
It also works for positive sign, but the absolute value of a positive sign will still give you that number. But if there is a negative, it will change it. So why I say that the reverse is not the case is that, let's say I have absolute value of 4 and it gives me 4. And someone is telling me that this 4 now, from which number did we generate this 4 using the absolute value? You can't tell because probably you did absolute value of 4 to get the 4, or you did absolute value of -4 to get the 4. So we can't reverse it. We won't be able to tell from whence it comes from. So I think, yeah. So when you spend time and look at this, and you'll be able to understand. Since there's no question and our time is far fetched or far gone or whatever, I'd like one person to present the assignment. Maybe one or two persons before the time is up. I just want to see what you did. Any group ready to present? If you're any group that just want to present, you can present now.
Ready, please, sir. So I'll just do my own and go.
All right, so share your screen. Let's see your work.
Give me permission, sir.
All right. You have my full permission.
Can you see my screen?
I think it's still coming up. All right, we can see it now. Please, the next person that will present, just open the notebook in your screen so that it will not take much time with the opening. It's like you just disconnected. Prince. Hello, Prince.
Can you hear me?
Yes, what happened?
I don't know. I've been shouting since talking since I thought like I was disconnected. That's why I stopped sharing.
No, we're not hearing you, and you were not, and your screen was still loading. Maybe could you try to fix it? Is there any other? Sorry?
I don't know what is wrong because if I start sharing, you guys are talking, this thing is breaking, like it's just as if you are stammering. I know I don't know what is happening.
It should be probably your network. Okay. Is there any other group that David Madupe, can you share your work?
Yeah, of course I can.
Please do. It's already open on your screen, right?
Yeah.
Okay, so
Can you see my screen?
yes, we can.
Okay. So this is just our group work. And we are talking about the parents class and the children classes.
Who are the members of your group?
Dunsin, Johnson Fayode and Dominic Shema.
You guys did it together?
Not really. I think I did it late, so I was more or less doing it on my own because I seem to finish on time before my. I don't know if they
Okay.
submitted before I finished.
Okay. Is it that okay, you guys, that means that they did their own separately.
Yeah. Because I submitted this one separately, differently after the deadline. The initial deadline.
Okay.
Yeah.
Okay, let me see what you did.
My parents' class was on medical device, and then I now had 2 children classes, diagnostics and implants. So for the parents' class, I used the keyword class and the class medical device, and then defined it using the keywords def and the function units. So the attributes I used were name, color, and the number. So I defined the different selves here, and I equally use the keyword to increase the number for this medical device. And then downwards, I describe the different attributes here. For the first, which is the name, is the PCR, and then for the color is red, and of course the number is 5. So I printed it in the next line, and of course, so when I printed the first one, I had 5, and then when I printed the increase, that's when I increased the number, I had 6 after the printing. So with that, I navigated to the first child class, which is on diagnostic. So I inherited the medical device from the parents class into this child class, diagnostic. And of course, I used the keyword defined and the function in it, and listed these various attributes for the child class. That's the name, color, number, diagnostic batch, and of course, diagnostic shape. Then for me to bring in the inheritance from the parents class, I use a super keyword and then the function, which included the name, the color, and the number. And then I define the various diagnostic batch and the diagnostic shape here. And then I included the different attributes, the SPR for this first child, the SPR, then brown for the color, and 8 for the number. And this is the diagnostic batch, that's 101B, and of course the circular for a diagnostic shape. And when I printed the diagnostic number, I had 8 as a result. So my second child class was implants, which of course followed the same pattern of the first child's class. So I inherited the medical device from the parents class, and then used the first keywords. Use the keyword def and the function in it, and of course use different attributes. Though the first 3 attributes were from the parent class, that's the name, the color, the number. And then these 2 were the additional attributes I added, that's the implant batch and the implant size. And using the super keywords and the function, I brought down the names from the parents classes, that's the name, color, and number, and then define them here. So here I had the different names for the name, color, number, the implant badge, and the implant size, respectively. And when I printed it for the first one, printed the first number, the first implant number, I had the result 4, which is one of the attributes here in this implant. And when I increased the number using the first function I used earlier, I had 5 as a result. So finally, to talking about the objects. So I used these different keywords for the objects: diagnostic 2, implant 2, diagnostic 3, and then these different attributes. So when I printed the different attributes using these keywords, I now got these results that was here. So I think that's the end of my assignment.
That's really nice, really great. Does anyone have any question to ask him?
Thank you so much.
I have a question, please.
Okay.
Why did you, your parent class, medical device, this medical device, I'm wondering, why did you annotate it to none? Does it have any specific or particular effect on your project or work?
No, it didn't. It didn't. I just added it as an extra addition.
So do you think that in the future, if another programmer should reuse your code, because this code are reusable, right?
Yeah, of course.
You remove the annotation, is your work going to misbehave?
Is my work going to be?
Is your work going to misbehave?
Misbehave?
Like, is it going to malfunction if they remove the annotation? Because I
don't
want to know if there's any particular work it's doing.
Yeah, that's another question I wanted to ask Mr. Anthony, because when I did it initially, it didn't
Which annotation, sorry?
This none, the none and the
Annotated it to none.
colon.
Okay, I think I explained it in the class then that you can remove it, but it is this thing. It is what do I call it? Forgotten the right word, like the style. Okay, it just tells us that that function is returning nothing. In fact, you're even supposed to use it in this increase also, because your increase is not returning anything. So assuming you write a function, a method inside a class, if not necessarily inside a class, generally, if you write a function, whatever that function is going to return, you have to put it in that pipe. If it is returning an integer, what you put there is int. If it's returning a dictionary, to be dict. It is returning a float. Okay.
So if then a dictionary, it is what?
Dict, capital letter D-I, I mean D-I-C-T.
Okay.
Dict, yeah. So whatever is returning, if it's returning a pan, whatever, you have to pipe it there. It's just to tell us this is what is returning. The same way we are doing it there, there's also a way of doing it for the argument is taking in to tell us the argument is accepting also. So this is just like a way of telling us what this function is returning. This increase, you're also supposed to pipe it to that none. You're supposed to put that same none also for that increase. Yeah, so that's just but even if you remove it, it still does not matter.
Yeah,
Just
yeah,
like
I did it. I did it. Yes, I did.
Used it there, and I'm wondering so much because this is a class, and this class, the body of this class is just some distinct attributes, and it's not returning anything specifically. And even if it is it always necessary to annotate it?
The fact is, even by default, like VS Code, by default will put it for you. Once you type that def underscore init and you close that this thing, it will, if you hit the enter in the like this VS Code, it will pipe it for you automatically in the init. So just now is a convention. The convention is you have to put the pipe to put the return what do we call it? The return type. Return type. Yeah, for here it's returning none.
Okay.
So it's not returning anything, so it's none. So it's not only for that init. In fact, in all your functions, you're supposed to pipe the return data type. So it's just a good convention to do it. Something I see in this work which does not follow Python convention is one, the class name should start with capital letter. Okay.
Okay.
Always. Of course, it will run without it, but it's a convention. If you're working in industry and want to write a class, the class name should start with capital letter. And apart from the class, of course, class name start with capital letter. The method name start with small letter. So in Python, like this increase number, some people talk about something like camel case. Camel case is increase. The increase will be all small letters. Then the number will be capital letter N, but there won't be underscore, just increase number. But the first letter in that number will be capital letter N. But that's a convention that JavaScript developers use. It's a convention used in JavaScript. But in Python, it is the increase underscore N underscore number. As you wrote it, correct. Okay. For functions or methods, small letters throughout. But for classes, the first character in the word or whatever should be capital letter. Then also this MD1,
Yeah.
it depends, but normally variables should be small letters.
Okay.
Yeah, it's supposed to be MD underscore 1. Okay, small letters. That's the normal convention. Apart from it, the work is superb. I mean, it's a super work. Thank you very much for the work.
Thank you
Does
so
any other
much.
person want to present?
So I can stop sharing, right?
Yes, please.
Okay, thank you.
Any person that wants to leave the meeting is free to leave the meeting, but it will be good if you just stay to watch people's presentation. So does any other person want to present?
Yes, sir.
All right, please.
I don't know why my distance is. Let me try it again. Can you see my screen now, sir?
It's loading.
You can see it now, I guess.
Yes.
Okay. So I just did something very simple. This is the parent class. Sorry, just a moment. Okay, so I just defined a class called company. Then I initialized 3 attributes: self.sales and self.salary. Then I defined a method that would calculate the sales and the salary. It's going to display the different amounts and then sum them up. Sorry. Then here, this is just the child class inheriting from the company. I just named it as employee. I've just put pass because I didn't have anything to put under it. This is customer also inheriting from the company. And when you run it, here I just had to, okay, I created a new object using the first child class, employee, and I put in the amount for sales and salary. And when you run it, it's going to give you the 2,000 and 5,000 we produce this. Then the second object, cost equals to customer. So I used the second child class to create this object. When you run it, it will give you this result. Then the last object I created is additional, which is I used again the first child class to create this object. This time around, I used a negative value, and just something very simple, so. And that's awesome.
Thank you very much for the wonderful presentation. So the audience, if you have questions, ask him. Before I ask him my own question.
Sorry, the question I have is that how did you inherit the class company from because I didn't see anything like super or something like that.
super keyword is actually is a magic keyword that they use to, I will not call it magic keyword actually, it's a keyword like, for instance, if I actually wanted to give this child class some attributes, if I give it any attribute, it's going to override the method I have created here in the parent class. So then, for it not to override it, I have to use the super this thing method. So that's why I'm not using it, because I just simply used pass here. It means I don't want to put anything in the child class here. That's it. So that's why I'm not using the super method or the super keyword.
Okay, thank you.
You're welcome.
Any more questions for him? Okay, my question now for you is, why did you create these child classes? I mean, when you are not, when there's no difference between them and the parent class, so why do we create them?
Actually, so you know, this is a group work, and we're supposed to be 3 in this particular group. So I couldn't get through my teammate, and this I did it the last hour to the deadline, because I was waiting, thinking I could still reach them so we could do something. First, I created, there was even, I did something more complex, more complicated than this, like a very foolish, thinking that, okay, they would join and they will create something to join it, but they didn't. So I had to like clear it and create something very simple. This was like during the dying minute. I could still find where I created something like that, like a very complex.
It's okay. I mean, we're actually interested in simple things, just something very, very simple as you just had now. Okay. So, all right. So that means that this work is not completed. Okay. It's okay. Thank you very much for that. Thank you. That was really nice. So, yeah, you can stop sharing. So who is the next? Who's the next?
I didn't hear anything you said, Master.
Okay, I said that you did a nice work. Congratulations. Thank you for that.
No, okay. Thank you so much, sir.
Yeah. So who else wants to share? Festus. Festus.
Yes.
I want to see your group work.
Okay. Hmm.
Okay.
Let's load this yet. This is going to take time. I thought I loaded this, but it's didn't load. Okay, well, I think I can open it with this. Can you can everyone see my screen?
Yes, we can see.
Yes, yes.
Okay. Actually, I use a club to create the parents class and also the subclasses. the children class 1 and class 2. So this is a function. This class is to return the player name, the age, the height. So I use this class as the name of the class is Leicester Club. Then I created this function. First, so this first standing for first name, then this last name, age, height. So and then self for first name, for last name, and then age for each. Then this for height. Then I return that full name should be return this space, this dot format, first comma last. So this should be the first, then this should be last. So that's why if I now have a player 1 as Leicester Club, which is for the class, then Jamie Vardy, age 35, 179. When I print player 1 dot full name, it will appear Jamie Vardy because I have already created a function that has to return the first name space last name same with age, print player 1 dot age. It will return the age just as it is in this function. That's the way it's going to print it at 35. So the same with the height. So just as this is the functions first, last, age, height. So once it's printed player 1 dot height, it will be printed as 179 as this. So the same thing goes with player 2. The player 2 is indicated as Leicester Club, which is representing this class. Then Harvey Barnes 24,175. So when you print, you can print player. It is just player. This you can decide to have. Print player 2 dot full name. This, and when I run this, and this is printed. I open this Jupyter. So this is better.
Can you go back to that Jupyter? Go back to the VS Code. Now try to run it again. Not from there. Not just look at this other arrow beside it. You don't necessarily have to run everything. Just go to your left. To your left, the arrow on top. Go up.
The arrow on top. Okay,
yes,
okay.
This arrow, yes, run it from there. Yes. Now connect. You have to connect to a Jupyter server. So you need to select a kernel. Click on that connect to a Jupyter server. Click on it. Yes. Let's see. Okay. I think you don't even have Python installed in your system. It's okay. Just go to Jupyter. Go to Anaconda and run it. Run from Anaconda.
This has opened already, so let me run it from here.
Yeah, because the Jupyter will ask you to install.
Okay. So I was saying the name of the class is Leicester Club, and then this is the function first, last, age, and height. As I've explained, self.first equals for first name, self.last, last name, self.age for each, then this for height. So and then I define a function. I define a function for full name that it should return this space this. That is this format. The format is first because self.first is first, so first and last. So it's going to return first name space because there's a space here. There's another there's another what is it called?
Is it
not
apostrophe or quotation mark?
quotation mark? There's another quotation mark.
Apostrophe, yeah.
There's another quotation mark in between, and there's a gap, which is I left that gap so that it will differentiate the first name from the last name, like a form of space. So, and I close close it to the quotation mark like a space. So, and then I now give an example. Player, my first player name is a striker, like Leicester Club. I use this class to give you Leicester Club, and then Jamie Vardy 35,179. So I now print player one dot full name in brackets is going to return Jamie Vardy for me. So let's say I run this. It's printed everything for me. So then let's say I want to do for the player two. I can decide to say print.
Festus,
Yes.
because of time, could you just summarize in the next 1 minute?
Okay. That means I have to go for the next.
Hey, Brentford, don't cut my ticket.
So just an unprinted player two full name. So and you guys can see have banners appeared because I've defined the function for the full name. So the same thing. Same for the child class. Same thing for the child class. The child class is player transfer. I created this. I created a subclass for this class using player transfer. That's trying to buy a player from another club for the then. So for that subclass to now be a player transfer sub, showing that it is a sub of Leicester Club, which is this first. So I have this first function as self, first, last, age, height, rating, transfer fee. So now already in the initial parent class, I already have self, I already have first, last, age, and height as a function. So I have to just indicate with this super dot initial first, last, age, height. It means what this shows is that it's going to take what is in the parent class, and then the other one that is on the parent class, which is rating and transfer fee, I have to define it, which is self.rating equals rating and self.transfer fee equals transfer fee. And I now created a function for the transfer. So what would be the basis to actually buy a player? So I now created a basis that when if the self-rating, if the rating is greater than or equal to 7, accept transfer, else reject transfer. That means if the rating is less than 7, the transfer should be rejected. Why if it is greater than 7, transfer should be accepted. So this is the first, this is a new player one. That is a new player one that is on the market and intended to be bought. So and then the new player one with the subclass will now appear instead of the Leicester Club. What will now appear is the subclass, which is player transfer, Lionel Messi, 35, 169, 10, 48,000. New player 2, the same Robert Lewandowski, 34, 184, 9. So if I print new player 1 dot full name, it's going to show me this. So let me run it here. Let me run this and then you'll see it again. So you see, it showed me this. I printed new player one dot full name. It showed me Lionel Messi dot age 35, which is this, dot height 169. Then print new player one transfer. So this transfer now is going to appear. So what is going to show me is accept transfer because it's greater than or equal to 7. This is 10. So 10 is greater than 7. So it accepted transfer. So the same thing happened here. A new player 3. You observe that Bruno Fernandes 27 179 6 25,000 euros. I now used that to show if the transfer will be accepted or rejected. So I now print new player 3 dot full name. It gave me the name of the player, Bruno Fernandes dot age 27. What is the height of this player? Print new player 3 dot height. It produced a result 179 cm. Then the transfer, new player 3 dot transfer, reject transfer because why? 6 is less than 7 because the transfer can be accepted if the rating is greater than or equal to 7, and 6 here is less than 7. So that's why transfer was rejected. So that is that for the first child class, the first subclass of the parent class. Then for the second subclass, I used player wages, which is sub under the Leicester club. So I raise amount by 4%. So then this function is just to show you what is added, which is P. Then this super is taking the format, trying to tell the program that already this is in the parent class. So whatever that is in the parent class will maintain status quo. So whatever is the parent class, whatever function that's to apply to first, last, age, and height will be taken from the parent. We'll take it from the function, from the class function that is in the parent class. And then the only one that is new here is P, which is now I created the function as self.p equals to P. Then I now created a function, subclass function for apply raise amounts for self. So self.p equals to self p multiplied by the self.raise amount, which is this raise amount. And then I now created an example, player 1, player wages, Jamie Vardy 35 179 42,000.
Okay. Summarize.
So the main thing out down to indicate here is that for this player, Jamie Vardy, when I printed player 1.p, it showed me this P for 2,000 euros. Then when I now apply this function, player 1 dot apply raise, that is, and I'm not applying this function to the player 1.p, and I now reprint the player 1.p. It showed me a new amount, is the new amount that is to be paid. So which shows that this amount has been increased by 4%. It's an increment of 4% to 42,000, so giving rise to for 3,680 euros. Then the same thing for the player 2, player wages, have Ibanez 24 175 200. So when I printed the full name, I printed player 2.p. This is the initial amount. Then I applied the increments in amount, increment in salary, and I printed it again. It shows 29,328.
Okay. Then I asked a question. Was this work done in group?
My colleague was quite busy, so
okay,
I said to do it on behalf of the group.
Okay, who has a question for Festus?
Question yakpa, but I start now, no go because I get many questions I want to ask here.
Okay, now hold on. I want to officially dismiss the class. Then those that have something to present, I'll be here. We'll look at your presentation together. And if any person still wants to stay behind to watch the presentation, you can stay behind. I want to make this announcement. For my own Python part of the class, this is how my project will look like. By Monday, I'm going to send you a link to write a test. It is a test for the Python part, and you have 1 week to write the test. So it's like to have multiple choice and maybe programming part also. So it will be a test, just like HackerRank test, but this one is easier one based on your level that you write. You have 1 week. Take your time, study. Of course, I'll tell you hints on the things to expect in the text. So you have like 1 week till next week ending to write the test. That's one part. Then the second part is the capstone project. I've been thinking, and this is what I want to do for the capstone project. I don't want to give you a project myself. Choose any project. Think about all the tools you've learned in Python. How can you create a project from it? I mean, is there any problem you could think of solving? Is there anything you think probably from your field? I mean, it could be something very, very easy. It could be something a bit complex, whichever thing. Just use your imagination. The tools you've learned, the Numpy arrays, the classes, whatsoever. Just think of something to just build, something to create. It could just be some lines of code to just write that will do some functionalities. We would like you to wow us on that day of presentation. Just remember, your presentation will be recorded. The videos, I mean, it will be a very standard presentation because I'll give you 2 weeks for that, no longer 1 week. The videos will be pushed on the YouTube. So your friends can get the link to go and watch your presentation. I mean, you can even use some of them for our advert or whatever. Just take your time and just think. And I would like you submit the decision of what you want to do. You submit it by Wednesday to me. I will create on Discord, I will create a channel for capstone ideas. From now to Wednesday, any idea you want to, that you know that, oh, you've come up, this is what you want to do, describe it. You post it on that link, on that, this thing, the capstone ideas. You just post it there that this is your idea, what you are thinking of doing. I'll look at it, then I'll say, okay, go ahead. So from now to Wednesday, you do that and you have 2 weeks to work on your capstone project and to present it. So remember, on Saturday next week, there'll be a workshop. That workshop, I'm inviting my manager, and I'm also going to invite an HR that will talk to us on some maybe about recruitment and the processes involved in recruitment in data science, particularly. And my manager at work, Lek, will also be available. He has agreed to attend also. He will talk to you on what data science and data analytics looks like in the industry. So these are the things. That's next week, Saturday. So that means as you're working on your capstone project, you will come to present. And then, of course, you have to come up with your questions. You need to ask him questions. You can ask him about whether there is internship opportunity in their company, and what it takes, what's the level of programming that they need for people. You know, just any question at all. He's a Polish, of course. So ask him any question at all that you want to ask him and all those things. So, but for now, just take note that I will still drop it on Discord channels. I will send you a link to write the assessment by Monday. Then you have to Wednesday to submit your capstone project idea. Then you have to 2 weeks time to work on the capstone project. If you have any question based on this thing I've just said now, you could ask. Then after that, then those that want to still present their work to me, I'll be here watching you and asking you questions. And those that want to join in the presentation can remember. Know that officially the class has ended. So any questions? Okay. Festus.
Yes.
First, I will say that you did this work yourself, right?
Yes.
Do you have knowledge of Python classes before now? Before the Python class, the class we talked about, classes?
No, I didn't.
Okay, you learned this thing from that class. Then, and you went probably, of course, you did some more research, right?
Yes, yes.
Okay, because I was wowed by your work. I mean, the ideas, the concept that you introduced, I mean, the way you used it for the transfers and all those things. I mean,
Yeah,
I didn't know you could go to this level, and I mean, it was very, very wonderful. Even your naming conventions, how you name the class, you use the capital letters, the way you name the methods, good. The way you name the variables you created, like player one, player two, they were Pythonic and very wonderful. Now look at
thank
this,
you
your
very
full
much.
name. Yeah, this full name, that string, you don't necessarily need to put all these things. Just remove all those quotations inside.
That full name, okay, the
Yes,
return string.
yes, all those other quotations inside, remove them.
Okay, like this.
Yes, put a space.
Aha.
Then hold on, run it, let's see.
Yeah,
It
it
ran,
still
right?
worked.
Good.
Yeah, it ran with the space. Yeah. Okay.
So you do not really need to add those quotations inside. Yeah, this is a very nice work. Super. Thanks for that. Bravo. So class, any person that has problem with understanding classes, I mean, Festus did a nice work. And also the other two guys that also presented their work, very nice. So you could reach out to any of them. Then I want to call on someone else. Of course, all of us here, you should have your work to present because all these people, there was only one person that volunteered. So as I was calling, they were presenting. So let me keep calling. Prince Charles. Are they running away?
No, no, no.
Okay. You guys should not run away, please. I mean, you can leave. Yeah, if you want to leave, but don't leave because I may call you. So, Charles, do you have anything to share us?
No, no, no. I don't have anything to show.
Okay. Paul Ekane. Paul, we can't hear you. Maybe you are muted.
I have a question, sir.
Okay.
For the last person that shared the
Presented.
presentation,
Okay.
I don't know if he has gone.
He's here. Festus is here.
Festus. Festus, hello.
Yes, I'm here.
Yeah, you said they bought Messi how much? Because
No,
that amount I'm seeing there. Okay, I think I have to ask you this question privately. Because
I think no. The amount I put there is just it's just for the presentation sake. It's not as
example,
if
that
there is
amount,
amount.
even in
It's not
example, amount,
as if yeah, it's not as if the amount players are being sold or something. It's just an amount I just put, like it's not that
okay.
that is the exact amount players are being sold or bought. It's just for the presentation sake.
Okay, no problem.
Yes.
It's an example. Try to
Yeah, exactly.
just try to increase the amount.
Yeah.
That's
All right. All right. We are seeing Messi fans here. Okay. So, Paul, are you back? Okay. Tower Cat, Ayodele. Tower Cat. Okay. All right. Rack. Rack. Okay, I think that means that's the end of today's presentation. I mean, you guys did great. Those are presented. Good work. I mean, the skills you've learned is just very few in data science that have these skills, these classes. I mean, very few. When I mean very few, I mean few. So just note that they have a very great advantage. If you go for an interview in data science and you tell them that you can also use classes, it's a very big plus. I mean, very, very big plus. Because one of the challenges one of the challenges is being faced in industries is that when data scientists finish writing their code, the data engineers will take the code and rewrite it, or the Python programmers will take their code and rewrite it in order to make it production ready. And one of the ways you could make your work production ready is by putting it in a class. So you already have a skill now that the other time in my company, we went for a workshop. So we're talking about, the workshop was for data engineers. Of course, my primary assignment is data science. So I was telling them that, oh, I'm not fully into data engineering. My main assignment is data science, but of course I like all these AWS stuff and things like that. They're like, yes, that the reason why they decided to invite me was because that they discovered that after writing code, when data scientists finish writing code, they have to struggle again to convert their code so that it will be automated. And these automation processes, they're like, okay, it's good that you also be here to learn the tools that the data engineers are using to automate the pipelines or whatever being built by data scientists. So you see that, so this class is a very added distinct to your portfolio. You can boldly put it in your CV. That when you're putting on the skills, Python, this thing, class, include the class. Let it stand out also. It's a very valuable skill to include. So thank you very much, everyone. Thank you for staying longer. So please, by Monday, you get the link, and please start brainstorming on your capstone project ideas. You have 2 weeks. It's very important. You learn a lot during this capstone period. I mean, you learn a lot. And of course, your TAs are always available for you. You could always talk to them, ask direction on your capstone and everything. So thank you, and yeah, see you next time, probably Monday.
All right, thank you, sir. Have a good night.
All right, good night.
All right.
Thank you very
So
much for
much.
tonight's
Good
class.
night.
Good night.
Have an amazing night rest.
You too.